So our next and last session before the keynote is Doing More with 3D Printing by Dale Askey. Dale currently serves as the Associate University Librarian for Learning and Library Technologies at McMaster University in Hamilton, Ontario, where he also occupies the role of Administrative Director of the Lewis and Ruth Sherman Centre for Digital Scholarship. He has filled a wide range of roles in libraries. McMaster is the 6th university to employ him, and Canada his 3rd country. As an administrator with a road of practical skills, fine motor dexterity is his most useful contribution to any technical project. I'm pleased to welcome Dale. Please join me.
That's a completely true statement these days. It's really awesome being Amy Buckland's warm-up act, by the way. I feel like some sort of opening. Yeah, let's hear that. So I thought after listening to Dan Scott's, and I know he's not here, but hopefully he's watching the live stream, after watching his talk on Dialed yesterday, and he took that poke at university librarians, so simple, even a university librarian can do it. And I'm not a university librarian, but, sort of sit in the same room, so to speak. So I thought about changing the title of my talk to being doing something with 3D printing, as in I can still do something useful, because I've lost so many of my skills, and everybody who works for me, John and Gabrielle and everybody else who's here, can run technical circles around me. So let me get started here, start my timer, make sure I don't botch that. So I just wanted to give you an indication of where we're going. Oh, I've got to pick up my pointer too, don't I? Oops. There we go. So I just wanted to give you a brief outline. So I'm going to talk a little bit about how we got into 3D printing. There's a few points to make there. I'm going to talk about 2 key insights from our experimentation and the work that we're doing regarding actually printing successfully. I'm going to talk a little bit about our future plans. We've got a lot of ideas for what we can do with 3D printing. And then I want to close with just sort of a brief discussion of the why of 3D printing in libraries. That's something that comes up quite a bit. Why are you doing this? So I'm going to close with that. So, why did we get into this in the first place? Why did we jump in to 3D printing? And if any of you were, well, for one, actually, as you know, the CBC has declared that 3D printers are widely accessible at libraries, and that's actually true, and it's happened very, very rapidly. But even though they're everywhere and they're ubiquitous, at least the language says that they are, in reality, people still really flock to these things. You can't have a 3D printer on a table in any setting without a large group of people forming around it. And for many of those people, if you listen closely, it's the first time that they've actually been close to one, and they have a lot of questions about basic functionality and are sort of amazed by it. And so these kinds of scenes are just replaying over and over again and still very, very common. So a lot of us who work in libraries think, yeah, everyone's got a 3D printer. It's just not true. So we don't have a really long history with 3D printing. That's kind of the irony of this talk, maybe. We didn't really even jump into this until 2014. We ordered that 5th gen back in January of 2014. And we got into it based on our own interests and some sort of general expressions of interest in 3D printing from some of the graduate students who are resident in the Sherman Centre. And one of the advantages of being in AUL is you can get these ideas and fulfill them without going through some sort of approval process. So no one had to come to me with a proposal. Thanks. Thanks, Terry. Yeah, you can just pick up your purchasing card and buy these things. So there wasn't a long process around this. We didn't plan. We didn't do a health and safety analysis. It was we just bought some printers. And they're not cheap, as many of you know, but for a library budget, and especially for a technology budget that's in decent shape in a decently sized library, a 3D printer is not an expensive thing to purchase. So could fit those in well without having to do any special financial dancing. So one of the immediate impacts of having these three printers in the Sherman Centre was that we were able to launch a public printing service shortly thereafter out of the Lions New Media Centre, which is also based in Mills Library at McMaster. And it's driven by now 2 Ultimakers. The first one was so successful that it had a 3 or 4 month backlog for print shops, because of course they can only crank out so many models a day. So we bought the second printer to try to deal with that. And this happened with zero marketing. We simply just opened the doors on the printing service, put it online, stuck the printer in Lions, and people find it. So again, to that point of the flocking, it just happens. And so we could have 3 or 4 printers in there, and I'm sure we would still have a backlog. So this has all happened very, very quickly. So what have we learned thus far? What have we learned about 3D printing? And as you know, as the saying goes, a picture says 1,000 words. You know, this is the box of PLA shame. This is where print jobs go to die. This is actually our recycling box, and if you know 3D printing, you can look at this and sort of pick it apart. So much of it's typical waste. It's rafts from a MakerBot or brims from an Ultimaker. There's some filament strands in there. There's the remnants of nozzle clearing projects and things like that. But a lot of the things in there are failed print jobs. You know, a lot of it just goes in the bucket as, well, that was a complete waste of 10 hours of electricity and plastic. And, you know, it just goes in the box. So the conclusion is that reliable and consistent 3D printing is incredibly difficult and very, very much a pipe dream. If you babysit your printer and constantly monitor it and constantly tinker with it, you can successfully print things. But for most people, that's just not going to happen. And so simple printing remains, like I said, very much a pipe dream. We also learned that the MakerBot was a complete and utter disaster. And I'd love to give a talk just on how much I hate MakerBot sometime. And I'm sure I could have a chorus up here of people, of MakerBot 5th gen owners who could sort of just riff off each other and explain how much they really loathe the name MakerBot. But if you've seen the movie Print the Legend, it's one of those Netflix original documentaries. If you've seen the movie Print the Legend, it makes perfect sense. Actually, it sort of diagnoses why MakerBot fell apart. And if some of you follow the news, they're actually being sued by shareholders now because they made stock price projections based on the sales of the 5th gen, which they haven't met because the 5th gen is a piece of well, crap. And so they're being sued by their shareholders. And it's, as much as I feel bad about the people losing their jobs, but I do not feel bad about MakerBot just getting abused by the court system in this case. So anyway, so the good news is that MakerBot pissed us off so much that we went out and bought other printers and had a lot more fun with those. So thank you, MakerBot. The two insights, we have some hopefully useful insights. So any of you in the room who do printing or are thinking about doing printing, this next slide will of course seem very familiar to you. So there are two major inescapable problems with 3D printing as it currently exists. One is what we can just call chronic under-extrusion, not enough plastic coming out of the head, hitting the build plate when you need it. And so if you have a 3D printer and you know what I'm talking about, raise your hand. Yeah, okay, chronic under-extrusion. Yeah, it's really, really, really bad. And the other one is just the general problem of build plate adhesion, getting things to actually stay put on the build plate. Or conversely, get them off the build plate when they're done. You break a model because you overkill it and you're like, now I need the sledgehammer to break it off, and you just snap it getting it off. Big problem. So this is what under-extrusion looks like. It leads to laciness in models. You essentially have gaps. You know, it's as if it were going and going and going, and all of a sudden a layer, a partial layer, or a full layer fails to extrude. It really weakens the model, and if it happens, you know, repeatedly in a print job, it's just garbage. It goes into the box of shame. And the core design issue behind this, or the inescapable flaw of 3D printing, is that you're feeding relatively soft plastic filament through a very brutal steel knurled wheel that has to grab it and shove it into a printer. And if anything disrupts that flow, whether not enough coming out the head or not enough or too much friction coming from the feed, that knurled wheel can very quickly eat into the filament, and then you've got under extrusion. So it's just sort of the inescapable flaw of 3D printing. So this summer, one of the things I wanted to do was set aside some time. This is the doing something. Set some time aside to sort of, you know, sit down and work intensively with the printers. And one of the things I was looking to do was address the chronic under extrusion problem. And previously, as we were printing, we tended to view it almost strictly as a hot end problem, meaning at the nozzle. It's something at the nozzle, like not enough's coming out, so let's crank the temperature up. And that's got diminishing returns. You actually begin to destroy your printer by doing that, and you also sort of bake the filament inside and create residue. So increasing the temperature is one way to do it. I sat there for the better part of a couple days, actually, running dozens of scores of calibration tests on the Ultimaker 2, and some of them you can see on the screen there. They're just these little rings that are meant to fail, and I just sat there and printed them and printed them and printed them and watched them and then stuck them on a board with the variables that were changing. And what was interesting was, after doing a lot of these, it's not the hot end issue. That's the one you always want to focus on. It's the guts. It's actually just the stupid feed. It's the friction that's inherent in the reel turning and the filament passing around the back of the printer through its guides into the printer. So friction is actually the great bugaboo of printing. So the good news is, oh yeah, I've got a video of this. This is one of these printing. If you could hit play on this video. So this is what I did all day. It takes 9 minutes, reduced to 16 seconds here in time lapse. And I sat there and stared at these things all day, watching for flaws. It's gripping, trust me. It's done. And this was a good one. This was with like the pristine, outcome of it. So, it works sometimes. My slides are stuck. Help. Next slide. Thank you. So you can fix, this is what I would call fixing under extrusion the inelegant way, which is tear your printer apart in a fit of rage. So this is the MakerBot, and it had, what we were actually trying to achieve here was just learning how it works. It's kind of an inscrutable machine. It's covered in plastic. We wanted to sort of see what was on the inside. And also it makes a bunch of noise, and so we wanted to see if we could sort of secure panels or put insulation in and shut the thing up. And also just take out, frankly, some serious frustrations. So we tore the MakerBot apart, and while we were doing this, coincidentally, we were at the same time doing the Ultimaker extrusion with the calibration rings, and it hit me, aha! Part of its problem as well is it's got this really fancy filament feed thing where you stick it in this drawer that disappears, which is basically just a friction-generating monster. And so if you rip that out and reassemble your printer with most of the plastic missing, which is what the picture on the right is, and feed the filament off of a coat rack, which is what that object is standing behind the printer, you can reduce most of that inherent friction. And the thing, I actually love the MakerBot now, sort of. It prints like a dream. You just modify the thing and voila. It's like a newborn printer. It's great. It doesn't look like a MakerBot anymore, but so what? Then there's the much more elegant way to fix under extrusion was with the Ultimaker. So if you look under that reel of filament there's basically like a sort of an inverted skateboard or a assembly line with two metal rollers that have bearings on the inside. And we did not design this. I found it online because there are tons of mods to deal with the friction in the feed element. But basically what this allows us to do is stick the filament directly behind the feeder motor and run it straight in, and that's the absolute least friction possible. It's going straight into the printer, and again, this has really revolutionized how well the MakerBot prints. So, the Ultimaker. And so the proof, as I'm showing in this picture, was that we were printing a bunch of these large Raspberry Pi cases, and these things failed miserably in the old regime. And after doing this work on both the printers, we printed just a series of these things for a project. And they just came out one after the other flawlessly without any sort of serious under extrusion. So we've solved some of our really long-term nasty printing problems doing this, which is great. With regard to build plate adhesion, the good news is if you buy a bottle of fingernail polish remover, stick it in a plastic bottle with some strips of ABS filament, and use essentially a dissolved ABS acetone glue on a bare glass heated build plate, so like an Ultimaker or a Taz Lulzbot or any printer that uses a bare glass build plate, you're in business. Stuff is awesome. At low temperatures, it releases its stickiness, and so you can just knock the models off the build plate. When it hits 60 degrees Celsius, it actually becomes quite tacky and will hold PLA down like nothing else in the world. So that's great. The bad news is that it doesn't work to hold itself down, so it doesn't hold ABS down. So ABS adhesion is something that still eludes us. So moving along, because I've got to keep going here. So what's next? What are we going to do after getting our printers a little bit happier? I would put the things that we want to do into 4 categories. So there's some experimentation we want to do, there's some design issues, there's some teaching, that's a big part, and there's also just sharing. I had a conversation with Laura when I first sat down at Access on Wednesday, and her library just bought a MakerBot. And I thought, why is the message not out that that's not the best printer to buy? That it's because there's just a dearth of information. We know it, but we don't say it except into a microphone at Access. Which, thanks to the live stream, will reach the world. So under experimentation, we want to do more printing with HIPs, high-impact polystyrene, ABS, and some of the exotic filaments like the labric and the wood filaments. All I hear, some of you may have more experience than we do with these things, they're basically just clog monsters. You're just going to totally mess up your extruder head. So that's going to take some fun. We want to figure out how to get ABS to stick to the build plate. There are some known tricks for doing that. And we also want to start experimenting with acetone vapor baths. And last year at the DLF, I spoke with a colleague from Georgia State, Valdosta State in Georgia, and they use vapor baths to take ABS models and melt them slightly on the outside to create these smooth, shiny models, and they did this for an art project, and they're absolutely gorgeous. So we want to start playing with that, obviously not in our space. We're going to do that in a chemistry lab. With regard to design, We want to move from being just consumers of designs. We're Thingiverse and Imagine downloaders, basically. We want to start actually producing designs and publishing them out, so that's a big deal. Want to get into some 3D scanning. We've done some ad hoc scanning, as you'll see in a minute, but we want to get more deliberate about that. And we want to do some custom modifications for our own printers. So we have an idea to use that coat rack thing for the MakerBot and actually build something that will be a bearing device that will hang on essentially a coat rack. But we need to be able to design these kinds of things. And if you've ever used things like Blender, it's very powerful, but it's incredibly difficult to use. It takes time. We need to do some teaching. We want to do a printer certification course. Lots of people want to come into the Sherman Centre, our grad students or their friends, and print, and then we end up having to repair the printers afterwards because they don't know what they're doing and they've created some wicked problems for us. So we just want to have a basic certification course and say, if you watch this, you can print without supervision. We also want to do some intro to 3D printing workshops, ideally to sort of get the ball rolling and then get some students involved at teaching those skills to other students. And last but not least, we want to do sharing. We want to get those product reviews out, actually write fair, maybe somewhat cheeky, product reviews about the printers that we have. Want to share our testing results. You know, there's no reason that anybody else needs to sit for a day and a half in front of an Ultimaker staring at calibration results if it's been done. You know, we just write it up and share it. And then we also want to make little videos of repairs and tuning steps, because there's lots of textual descriptions of these things. But until you've actually seen it done, it can seem rather mystical. And so you just want to be able to see a video of like, yes, you can pull on that. Nothing bad will happen. And then the big last question is, why do all of this? How do we justify it? How can we sustain this program in times of austere budgets and so forth? There's a number of things we do that I think sort of get into this justification. One is we have a lot of practical fabrication needs in the library. We would call this practical printing. There are things you just can't buy in stores, or that the thing you would buy in the store would be not quite what you would need, or it would be difficult to source, or it would take forever to get there, or be very expensive, or some combination of the above. So we now have, in our building, we have servers and desktop computers that have 3D printed modifications inside, like the drive carrier in the middle that's sitting in a server, or the drive carrier on the right is sitting in a staff member's tower where we wanted to rip out the 3.5 and stick in an SSD. Sure, you can buy those kinds of things, but for older chassis, it's actually rather difficult. You can 3D print them in about 5 minutes. The pie cases I mentioned earlier are another one where if you want a specific kind of pie case to stick on the back of a TV, those aren't really even available from people like Adafruit, or if they are, they're expensive. We also have a lot of research fabrication going on, and we're pretty excited about this. So really quickly, we had a student who was a graduate student in the Sherman Centre who was an astrobiologist. Who knew there was such a thing? But there is such a thing as astrobiology. And he printed, these are microbialites. They're rock formations that grow in the bottom of specific lakes on the planet, and they're used sort of for exobiology studies for life on another planet, as evidence of life processes on other planets. I don't understand this stuff. But at the top on the right, those are the actual microbialites. Below that is his work with Autodesk 123D to capture them with an iPhone. And at the bottom are the 3D models. And the NASA people he works with were just ecstatic about this and were asking if they could get them in pink and green and all sorts of cool colors. But for serious purposes, and so there's a lot of that. We also have a new researcher coming in who is doing work with service animals and needs to attach sensors to them to track their movements and their reactions. And these, you can't go to a PetSmart and say, hi, I need to be able to attach an accelerometer to my dog's collar. Do you have one of those? You know, that doesn't exist at PetSmart. And so she came specifically to us in the Sherman Centre because she knows we have these research 3D printers. And last, not quite last, but anyways, what's the point of this? It's not about printing. We don't want to make people expert 3D printers. We want them to be expert at the design and creative processes that 3D printing can realize. But being an expert, I'll do that, fine. I've got my little fine motor skills. I'll be the guy who can rip the printer apart and make it work. But it was only 20 years ago, really, when it became sort of child's play to print onto paper. If anyone remembers early lasers and early inkjets back in the 80s and 90s, they were mercilessly nasty to use. And that's where 3D printing is now. And so rather than having people become expert at hacking printers, let's make them expert at actually the creative processes that go on behind it. And so this is, I consider this sort of part of Ranganathan's fourth law, save the time of the reader. This is saving the time of the user. We want to enable something. Let's take the hard work onto ourselves and let them do the fun and creative and intellectual stuff. Going real fast, I swear. And we want to foster experimentation. So a couple years ago at Access, I was on a panel and we were talking once again about we need to be able to foster failure. And I said, no, we need to stop calling it failure. We need to call it research and development. And 3D printing is a very visceral, very practical, very tangible way of sort of fostering that. When print jobs fail, they fail gloriously. And you can explain to people what they did wrong. This is not playtime. This is iteration. It requires research. It requires repetition. You have to keep going back at it. And it resembles bench science in a lot of ways, where you have to basically do something, try it, change a variable, go back and do it again. And so we're trying to sort of build that cycle into what we do with 3D printing in the Sherman Centre. So wrapping up, I just want to say thank you and give you some, how to contact us or come see our printers or come hang out with the MakerBot, because it's so quiet and awesome now. And then I have one more slide that I have to show, because this talks, I just said, well, we need to have videos, we need to have product reviews. And so actually what I'm going to try to do after this is I'm going to take the live feed, the capture of the live feed, and I'm going to create a director's cut. And so here's a preview of the director's cut. So if you could hit play on this video. Sorry about the face. Hi, my name is Dale Askey. You may know me from such exciting Access talks as doing more with 3D printing and we love open source software, but no, you can't have our code. Watch this space for an exciting director's cut version of my 3D printing talk. It will include live action 3D printers, other stuff that I can't think about right now. It's going to be awesome, trust me. Thanks. I'd be happy to take any questions or comments, or I know I've got maybe like 1 minute. I see why people have problems seeing hands. Holy cow.
Have you tried printing with other stuff, like ceramics or like bread dough or blood?
No, we're kind of... No. We're pretty simple-minded there. We mostly PLA. Like I said, we're sort of tinkering with ABS and have had some bad results. And we have these boxes of like lay bricks sitting around and some flex PLA. But all I read about are the horror stories about nozzle clogs and things like that. So we've been a little bit chicken. But just next week, actually, I'm going to put in an order to LulzBot to buy a number of exotic filaments, as well as cleaning filament, which helps you deal with the outcomes of using these things. It's going to be a while for bread dough, and if people are printing in blood, I kind of want to see that. That's kind of awesome. But we'll get there.
Did you start with the Gen 5? Did you have any experience with the MakerBot 2 or any of the other versions of it?
No, and ironically, those are the printers, no direct experience, but we had a lot of secondhand experience from people who had the earlier MakerBots, which were, of course, far more reliable, far more sensible machines, which is what led us to buy the 5th gen. And John's not here, and so I'll say it, and he feels really bad about this, and I've absolved him of his guilt like 1,000 times, but he still feels guilty. He was like, hey, when we were looking at buying one, and we were about to buy a 2nd gen, or whatever they were called, the Replicator 2, and they had announced at CES the 5th gen. He's like, well, maybe we should hold off and buy the next generation and buy the new printer. So I delayed the order and sort of pre-ordered a 5th generation. And he still feels really bad about that. I mean, I tell him it's been great actually, because we probably learned a lot more by having a 5th gen and hating it than we would have just buying sort of a well-known, well-trodden replicator. So yeah, it's kind of what led us to it. But yeah, you make your own mistakes. And good, yeah. One of us should write it up and explain to people, like, avoid this thing. Great, thanks.